Hi everyone, so it's time for a new topic, measures of location and spread, which is a really exciting one as far as I'm concerned because it's got a lot of really appropriate applications in real life. And you may be wondering what it means and why are you saying measures of location and spread, and then I can see the words mode, mean and median. I know those are averages, and that is what we mean by a measure of location. We're really talking about what the middle value would be, the most typical value, all that sort of stuff. But how spread out data is also very important. How spread out data is also very important because that tells us how predictable our data is. And so how we pin that down is going to be very important. But for today, we're going to be making sure we know what we're doing with the three averages and how to find values given certain bits of information, but not necessarily the bits that we would expect. So I'm sure it won't be news if I tell you that the mode is the most common value if you've got a set of data. But what's important for us to think about is when is that going to be useful? One reason why it's really important to have the mode is it allows us to find an average of qualitative data as well as quantitative. The other two averages aren't all that useful if you're looking to find out what the average is of a whole load of different colours, and it may be that the yellow is the mode, but there's no way of having a numerical value about yellow as opposed to red and all that sort of stuff. Well, there might be, but in many cases not. But when it's coming to quantitative data, you really do want to have specific values being used, and you're going to need to have values coming up more than once. If you haven't got any data appearing more than once, you won't have a mode. And if you've got lots of different values at different bits that are coming up twice, then you have a whole load of modes, and that's not too useful either. So as I said, useful if it appears more than once, but also particularly useful if the values that you're getting the most of, you only have one or two. So if it's two, it's called bimodal. Once you get more than that, it can become a bit more annoying really, and less useful. The mean is often called the true average, and the reason for that is because it uses every single data value, so all the data is relevant and just as relevant as itself. So in many ways you could say it's the fairest. So generally you'd want to use the mean. However, if you get extreme values, one or two extreme values, either very high or very low, they can make your mean skewed. I'll give you a little example. You might have a load of, I'm not even going to bother saying what this is. You may have a load of values about like this, and you might have 20 or 30 like that, and then you have one value that's as big as 1,000. Now, if you were to work out the mean of those 5 numbers, you would get 2 plus 5 plus 4 plus 8 plus 1,000 all over 5. And that gives me 203.8. Now you can see that 203.8 is no way typical of our data. It's way too small to be relevant to that one, and it's way too big to be relevant to those. And this is why the median is very often more useful. So let's see how that would be useful with our data that we've got here. So we'd just put it in order first, wouldn't we? 2, 4, 5, 8 and 1,000. We've got 5 data points, so just as a reminder, 5 points, you add 1 to how many you've got and divide it by 2. That means we would want our third because that's in the middle. So 5 would be the median, and that would be a much more acceptable average, and it means we can forget about that one. And I'm particularly thinking of if that 1,000 had been there and there had been 20 other numbers that had all been low down here, we would still have a median around about there, but we would be able to ignore that massive value. Okay, so here's our first example. Pause the video and have a go before watching me talk through it. Right, so we've got 25 observations and the mean is 6.4. Now, one bit of noting that you'll need to know about is that we call the mean x bar, and there's a function for that on the calculator which we'll go into at another time, and we can say that we calculate that by adding up all the values we've got. That means sum of, you may have seen that on an Excel spreadsheet, and then we divide it by how many we've got all together. So this is the sum of the values, and that there is the number of values. If you haven't written that down, pause it and write that down as a really essential little formula there. So what we've got is we're being told that the mean is 6.4. We know that we've got 25 observations, but we don't know what the sum of x is, what the sum of all the observations are. But we can do that by multiplying by 25. So I can say the sum of my x's is going to be 25 times 6.4, which is 25 times 6.4, 160. Then we just need to do the same thing for the second sample of observations. So I might call those y. So we know the mean of y is 7.2. So the sum of the y's will have been divided by 30. So I can say that the sum of the y's is going to be 30 times 7.2, which is 30 times 7.2, 216. So the mean of all 55 observations is going to be, what shall we call that? I'm just going to call that m bar, is going to be 160 plus the 216, all divided by the 25 plus the 30, which is 376 over 55, and we should give that as a decimal really to 3 significant figures. So we've got 6.836, and that's recurring, isn't it? So it'll be 6.84 to 3 significant figures. Here's our second example. Rebecca's been recording shirt collar sizes, so you need to work out the mode, the median and the mean. Pause the video and give it a go. Right, so the mode is the easiest one there, isn't it? It's just the most frequent, the one that happens the most often. There are 34 16.5, so 16.5 because there are 34 of them, which is more than any of the others, but that's your answer, isn't it? 16.5. The median, right, so this time we're going to have to work out what's the middle value. So if you add up 3, 17, 29, 34 and 12, you get 95 values. So what we want is the middle one. So we find that by adding 1 to it and then dividing by 2. So we want the 48th value. Now how do we get that? Right, in the first one we've got 3 plus 17 equals 20. So by now you've got 20 people involved. Now another 29 gets you to 49. So that means that the 48th result is a 16 and the 49th, and then the 50th would be that one, wouldn't it? So the one we want is that 16 there. So for that reason we can say that the median equals 16. the final one is the one that takes a little bit more in the calculator to do. We're going to need to multiply the values we've got by how many we've got of each of them, and then divide by how many there are all together. Which means doing something looking like this. Now you can put it straight into your calculator like that. You don't need to put brackets around the timesing bits because the calculator knows BIDMAS, so it will do that for you. And if you do all of that, and you could on the bottom have done 3 plus 17 plus 29 instead of straight writing 95, that should give you 16.18, so that would be 16.2 to 3 significant figures. And then we've just got one more part of this question for you to think about. So here it is. Why might a shirt manufacturer use the mode when planning production numbers? And that's simply because this is about real results and about which size is being wanted the most. Now our mean is telling us 16.2, our median is telling us 16, so we know it's somewhere between 16 and 16.5, but in terms of how many people are actually wearing 16.5 shirts, there's 5 more of them than there are wearing 16. Now that may just be the way it worked out in her year, or it may be something which would be useful. Certainly the shirt manufacturer who's selling shirts in that town would find that useful to know. Okay, all we need to do now is have a few for you to have a go at. Right, we're going to have 3 questions for you to do. Shouldn't take too long. Here's the first one. Pause the video and give it a go. So for the visibility for each month, you should have for May just be doing your total amount is 724,000 divided by 31, and that should have given you 23355 to the nearest whole number. I think it was 4.8 exactly, and that would be meters, wouldn't it, because it's in meters. So always make sure you put your units in. June, you should have 21,067 to the nearest meter, and then finally for both of them, for part B, you need to be having the total amount seen, the total visibility altogether is 724,000 plus 632,000. Put that all over 31 plus 30 is 61, and that should have given you 2229.5 meters. And I guess if we're being consistent with what we've done there, we should really be saying 22230, shouldn't we? Round it up to the nearest whole number. Although if it hasn't said, strictly speaking, should have all been done to 3 significant figures. But as long as you say what you've left it to, that's what's important. And you've shown you're working. Here's the second question about the number of times lorries break down for a haulage firm. Pause the video and give it a go. Right, so you should have got the modal number just means the mode. So the mode is, well, there's 12, there's more than there, so it's got to be 2. For the median, you need to find the middle one. So if you add all of those numbers up, that is 36. So you'll have to do 36 plus 1 divided by 2 is 18.5. So we're halfway between the 18th and 19th. Now the smallest 8 there, 8 plus 11 makes 19. So the 20th will be just in there. The 18th and 19th will be the last 2 ones there. So that'll be a 1. And then for the mean, you just need to multiply all the breakdowns by the frequencies and divide it by 36, which should give you 53 over 36, which is 1.47 to 3 significant figures. And then this is one of those ones where it doesn't matter too much what you say as long as you can justify it. In the in the book, it reckons you should say the median because that's the lowest number, and therefore that looks better because you can justify it. But I personally would have put the mean because it's the truest average, because it's representing all of the breakdowns there, and I wouldn't want someone to be able to come back to me and legally challenge me on it. But so either the mean or the median would be fine. I don't think it's really possible to, I don't think you would want to go with the mode, because that is more, and it's not even as true either. And here's your final one, bit more of a problem-solving-y one here, so do pause the video and have a good go at this before you check on what I do for it. So what I would say is, well, I know in order to work out the mean, so the mean is 1.5, and you would do that by doing 7 times 1, and you would do p times 2, and you would do 3 times 2, and you would divide it all by what all of that adds up to, which is 9 plus p, isn't it? So if we simplify that, that gives us 13 plus 2p over 9 plus p is equal to 1.5. Now, to solve that, first of all, you could just say, oh, we're going to have we could multiply both sides by what's underneath, couldn't we? Give us 13 plus 2p equals 1.5 times 9 plus p. Now, you might not like having the 0.5s and stuff in there, so you might just want to double everything. 26 plus 4p equals 3 brackets 9 plus p. Then expand the brackets, equals 26 plus 4p. Now, if I take 3p from both sides, I get p. If I take 26 from both sides, I get 1. But you could have done it by multiplying those out as well, and then doing it that way would have been just as good. Right, that's it for this week, folks. And next week we will be looking at measures of spread, I think. But anyway, we will find out.